Hello, my name is Nicholas Maxwell, and I'm going to be doing the 20 Hertz part of Project 3 for Dr. Ozbay's class. First, we're going to start by getting fluid flow fluent here. We're going to initialize geometry and make sure it's 2D. Once we get into here, we're going to want to do a new design modeler geometry. And this one is going to be a little more complicated than the past couple because it's going to be more of a shape with the chambers for the wind tunnel rather than just one constant, like either a rectangle or a simple slope. So we're going to go here, we're going to go to the XY plane, and we're going to want to go to sketching, create a line, just start drawing out the basic shape here of what this should look like. It should be something horizontal here, line down, line across horizontally, then finally a line up like so. And then we're going to want to go to dimensions. We're going to do the vertical dimension of this line and the plane here. We're going to want this to be in inches. So we're going to go to units. Let's make sure it's in inches. We're going to want this to be for the test section height. What we're going to do is we're going to do half of the height here. So we're going to do 3 inches here. Oh, just 3. It's going to start looking a little odd because of the scale we started in. That's okay. We can fix that later. Again, another vertical place here, and this should be half of the height of the initial one, so it should be 11 inches here. Then we can start doing the horizontals. So we can do this to this point. This should be how many? 15 inches. The contraction chamber from here to here horizontally. We have or no, that was for the settling chamber. For the contraction chamber, it should be 24 inches. And then for the testing chamber, I believe, test section, yeah, it should be 12 inches. So let me get that. And then the last one is going to be an angle measurement, as well as length. So let's make sure I get the length done first here. It should be 42 inches. And then the half diffuser angle is 3 degrees, but sometimes it won't get the right like plane, so you have to do like kind of some work with it. Because sometimes it likes to be, yeah, like see here. Um, Actually, that should work as long. Yeah, see, it's gonna now. I'm gonna need 357 degrees because it's doing the exterior instead of the interior angle. But now the interior angle should be fine here, like that. Great. Now once we have all of these defined, what we're going to want to do is we're going to want to go to our select tool. We're going to want to do a box select here, grab everything. Did I make that a line there? I did. That's fine. Technically speaking, that doesn't do anything. Yeah, it should be. Actually, yeah, I want to get rid of that because we want one inlet. I don't want to have to deal with two. So let me do something really quick. Before that, let me grab this line. So can I do that? Grab this line, delete it. And that should be fine. Now we're chilling. Now we should be all good. Now we want to go to the box select here. Select all these. Then go to modify. We're going to want to replicate. Make sure this is at 180 degrees. Take this, right click, and we're going to want to flip vertical. We're going to make sure we line that up pretty close with this because we're going to then now draw the lines between these because you want one inlet and one outlet. Make sure this is vertical with that. Okay. And then we'll make sure this is vertical with this. Okay. Should be good here. And then we want to make sure that, again, these dimensions are also correct for these. Yep, that's in the 15. Good. From this to this should also be for 24. Yep. Yep. This one to this one. Yep. This one to this one. Oh, model over constrained. Okay, we don't need that. Okay, so control Z on that. That's fine. And then we want the vertical height between these two to be, make sure that is, instead of 24 point that, we need that to be 22. And then the height between these two, make sure that is, that should be 6. There you go. And then also make sure that this angle is correct. This and this. That should be 183. 183. Great. And that should make this, again, once we add that brick line's already there. Cool. Now what we can do is go out of this tool, go back to the selection tool, and do a box select everything. Concept, surface from sketches, apply. So it should be showing up. Maybe just be taking a second. Oh, generate it. With that, we can now see this. What we can also do while we're here is go to sketch, make a line across this, because we can use it as a midline later. And that'll help with some of our points later on. But with that, let's save this project. Once that saves, we can go out of this, back to the workbench, and we should be able to start working on our mesh. So we can open our mesh here. Yeah, once this loads, it's going to take a sec, but hopefully not too long. It's going to take a sec. Hey, there you go. We can do here is wait for this to be completely done. Yeah, it's still loading. Ah, there you go. Now it's loaded. Great. We go to our mesh. We want to do, well, first we want to name these. So create name selection. We want this to be the inlet. Here we want this here to be the outlet. Create name selection outlet. And then what we're going to do is we're going to control click all these edges here because we need this to be the top wall, but we want it to be all one section. So top wall. Same thing here along the bottom section. Oh, not the face. Make sure actually I'm only on edge select. That way I don't accidentally select something else. That we're going to want to get create name selection. This will be bottom wall. Great. And see, we have all those. Inlet, outlet, top wall, bottom wall. Great. With that, we're going to want to go to sizing of this wall right here. Apply, there you go. And instead of element size, we're going to want to go to number of divisions. We're going to make this 1500. We're going to want to get capture curvature. We want to turn that off. We're going to want to go to hard. And we're going to then want to do the same thing on this side. Sizing. Instead of element size, we're going to go to number of divisions, do 1500. And then we're going to capture curvature. We want to hit no, hard. And then what we're also going to want to do here is go to sizing. Cancel on that. I want to go to the face though. We want to size this face. Apply face sizing here. I want to do element size, but we want to turn this down to 0.0. Is it 0.001, I believe? Yeah, 0.01. We're going to want to turn off capture curvature. Make sure it's on hard. And with that, we can then go to update. And when we go back to our mesh here to look at it, it should be pretty clear, the visual. It should look kind of like small little boxes, but almost like diagonally towards the flow to make a lot of nodes once it loads. We should see that here in a sec. Taking a second. Hey, there you go, mission. Perfect. See, this looks great. Exactly how we want it. With that, we should be good with our mesh. Should be all generated. Let's go back to our workbench here. We can go to our setup. I want to double click on this. It should bring this up. We want double precision. I'll do 2 solver processes just so it goes a little faster. We can start this up. And from here, it should be actually quite simple. You have all the setup done. We simply just need to change a couple of things on the panel over here once this all loads. And then once we do that, we can collect our data. So let's change a couple of the settings here once this loads in, which it gives a nice representation here when it kind of finishes loading in of the wind tunnel. Yeah, it looks nice. What we're going to want to do is we're going to go to models. We're going to want to first make sure our viscosity, we're going to want to be on laminar. From there, we're going to want to go to materials, fluids, let's go to air, make sure it looks good. Should be fine for this. Again, this won't change much in terms of the stuff because air flowing through it should be pretty consistent. It's incompressible, so that should be fine. Cell zone, that should be that. Just double check this is the air flowing. Cool. Oh, close that. Boundary conditions. This is where it really matters. The outlet and the wall outlet, pressure outlet should be regular. No gauge pressure should be fine. The inlet, we need to change it to our velocity, which given our frequency of 20 in the equation, we are given our velocity comes out to 4.6062 meters per second. So we need to apply that here. With that, we're then going to make sure that this is also at the center, because that's the thing is when we're making this, we don't want to make it starting from the bottom. We want to make it in the center, which is what we did. So normal to boundary right here. Great. Should be good. Should be at the center of that anyways. From there, we want to go to our, not, is it residuals? Yes, residual monitors. Let's change these to 1e to the -7. Oh, there you go. 1, 2, 3. There you go. That way we get a bit more accurate results. With that, that should allow us to then go to initializing. Let me double check, make sure we have that done. Yep. That should be all we need from that. Initializing here, initialize this. Sure, that's all good. Go to our calculations. You can do 150 iterations. And then we're going to want to calculate this. And yep, these are looking right. Looking like the flow is going correctly. Nice. From that, we're going to go to our graphics, contours. And here we can get any of our contours we want. We can start off with the velocity magnitudes to save and display this. You can see right here, this is the velocity magnitude. We're also going to have to go to the pressure. Want to display static pressure, that looks right. The dynamic pressure, which kind of also looks right, because then when we look at the total pressure, it's pretty consistent throughout the center line, which is good. We want that. And then what we want to do with those is we want to go to the plots. We're going to get XY plot. And then for each one of these, we're going to want to write to file, but we want to make sure it's on the, we want to use a new surface here. I know I made the line earlier. What we can also do is, again, set 0. The length of this line given to us in inches, we can convert to meters, which ends up being 2.362 meters. Actually, 2. That's a little more accurate. Creating this, we then can use this line as the center line to take all of these values from, write to file for each one. Well, first we can show them here. You can see these plots. Static pressure, you have the dynamic pressure. The total pressure should be pretty kind of, it looks wonky, but it's just because it's so zoomed in on a scale. Overall, it stays around the same values. It's just very, very small scale. And then velocity should also be very similar to how I believe it was either the dynamic or the static, maybe the static. Nope, dynamic. Very similar to the dynamic pressure in terms of the shape. And with that, yeah, write to file. You want to write it and make sure I do this with .text instead. I usually make a new folder on my desktop. But yeah, that's all the steps for this project, for the wind tunnel project. Thank you.